Hello, and welcome to this session on unlocked packaging. My name is Aidan Harding, and I'm the head of development at Nebula Consulting. We're a consulting partner based in London, and we have currently 4 of our customers using unlocked packaging to manage their code. We also use it for managing our own internal libraries so that we can install shared code onto multiple customers at the same time. Tiny bit of background on myself. I've been working in Salesforce for about 9 years, but before that I was a software engineer and studied computer science and things. So in this talk, what I plan to cover is the what and the why of unlocked packaging, not really the how. So there's a lot of good documentation from Salesforce on Trailhead and in the developer documentation on how to actually build packages, what command line things you need to put in. But the interesting thing here is, what is unlocked packaging? Why should I use it? Is it appropriate for me? That's the kind of thing we want to talk about. So what is unlocked packaging? It's a way of grouping together some of the functionality within your org. So if you think of a typical Salesforce org, there may well be vertical strands of functionality for different areas of the business. So there could be an HR strand, a delivery strand, a support strand. And you might have implemented those in your org using some kind of managed package, or you might have your own custom solution. And the idea behind unlocked packaging is that if you have your own custom solution, you can put a boundary around each of those functional areas and handle them separately. So one of the big changes with unlocked packaging is that when we're deploying our custom code, instead of using the metadata API that we're used to, we start by doing package installations as we'd be more used to with managed packages. That's generally a much simpler process. So whenever I'm looking at a new Salesforce tool or technology, there are 2 big questions in my mind. One is, how stable is this? How mature is this product? And the other is, what can I do if I start to go down this path and I find that it just doesn't work? What's my backup plan? So for unlocked packaging, it's been generally available since winter 19, and we've been using it at Nebula for a year or 2, and generally, if you stick within the kind of core features of unlocked packaging, it works really well, and it's been a very good experience for us. Later on, we'll talk about some of the things that you might want to be wary of or avoid entirely. The way that unlocked packaging actually works is that it attaches the label to your metadata components to say which package they belong to. So actually, if you start off down this road and you find that there are some complete showstoppers with unlocked packaging, what you can do is go in and just remove all the labels that say that things are associated with an unlocked package and go back to the traditional development model. One of the really nice things about unlocked packaging is that it uses a Salesforce DX source format, which is much more atomic. They've broken down all the objects into much smaller files. So when you make a single change, that's usually more localized, so that when you're working with source control, the difference between the old and the new version is much clearer and much easier to understand. One of the big changes between unlocked packaging and managed packages that you may be used to is that you have much more flexibility after you've released and installed a package. There are actually changes that you can make in unlocked packaging that you couldn't in managed. So if I've released a global class in my unlocked package, I can fairly freely delete that class. So it means it's much easier for me to tidy up dead ends, redundant code and things. That's a much easier thing to do. Namespaces are another notable thing that's handled differently. In a managed package, your package will have one namespace, and that's the only package that can use it. Whereas with unlock packaging, you can have multiple packages under the same namespace. So, for example, our utility libraries, we all have under a namespace we've called nebc, and there are multiple packages sharing that namespace, which is good because otherwise we'd have to make up an artificial namespace for each one when conceptually they're all kind of the same thing. So one question is, how does your org look today? And here's a picture from Salesforce in some of their unlocked packaging material, where everything's very organized. All the little woodland creatures are carrying around the boxes, but realistically, hardly anyone's org looks like this. And if yours does, I tip my hat to you. Much more likely it'll be potentially something like a spaghetti org, where everything is tangled together. There are lots of interdependencies between these areas that we see as separate verticals. The code might well all be tangled together like this bowl of spaghetti. And it makes it very hard to pull out a single portion, a single piece of functionality without all the other spaghetti sticking to it and us pulling out more than we originally intended. And if you look at this metaphor and how it applies to unlock packaging, what unlock packaging is doing is it's providing you with a number of bowls to put the spaghetti in, but it's not actually helping you with the process of separating out those portions. And if you're starting off from an org which has this big kind of spaghetti architecture, you have to recognize that your first problem is sorting out the spaghetti architecture before you really worry about the Salesforce technology of unlock packaging. And one of the things that we found from applying this is that it's a good idea to not try to fix everything in one big step. And the flexibility that I mentioned before about unlock packaging is really useful in that way. You can start off by making packages that are bigger than they should be. Rather than each package only having one concern, it may have 2 concerns or 2.5 concerns. And then we can move things around later, and we can just move through various steps, which are better than the last step, but not necessarily the ideal endpoint that we want to get to. So on that note, there are other pasta-based architectures. You might have a lasagna-based architecture, where you've separated each of your layers of functionality into a single sheet of pasta, so there's a clear differentiation between them. But the slightly scary bit architecturally is that there's this great big wide meat sauce interface between each of the pasta layers. What this is in Salesforce is the database. Once we've been living in the Salesforce world for a while, we kind of forget that the database is this giant global variable that everyone can write to and everyone can read from. And there's not necessarily much control on how those things happen. One of the reasons we break things into modules is to make it easier to understand the system. And it means that I can understand a modularized system by looking at the interface of that module. I know what it can do. But if the interface of everything is this giant global database, this big meat saucy layer, then it's actually quite hard to tell what the scope of each of those packages is. So one of the things you could do with unlock packaging is you can start to actually break up that database. You can make it so that some of the packages only know about a subset of your custom objects or tables. So it's not quite such a wide interface between each of the packages. You could also use something like platform events to narrow that interface as well. So let's look at a actual implementation that we've done with unlock packages. This is for one of our customers called Rock Choir, who organise singing groups all around the UK. One of the things that makes them an interesting case is that they have around 30,000 members and less than 20 Salesforce licenses. Their members are interacting via community, so they're continuously needing to change data, make payments, raise support cases. And because of that ratio between the members and the staff, Salesforce has to do quite a lot of work to enable the office staff to be able to deal with that many people. So looking at the actual packages here, what we've got here is quite a common pattern that you'll see amongst people who've used unlock packaging, that we start off with a base package for Rock Choir. And the base package defines all the objects that are fundamental to their business. So in the same way as Salesforce defines account and contact and their base objects, Rockwire layer on a few other objects which are fundamental to them. So they have choir sessions, they have attendances, they have terms. All these things are defined in the base package, along with a small amount of Apex to enforce some kind of invariance on those objects. So if we're doing some code-based lookup, roll-up summaries, then they might go in there. If we're preventing deletes from Apex, then they would go in there. And then we're going to build on top of that. You can see here that the base package depends on one thing. That's our own Nebula library that we install in pretty much all of our customer orgs. And that brings in our trigger handler framework and various other bits of Apex to make it easier to generally write the kind of code that we want to. Then we look at a particular feature package for Rockwire is their sessions package, and this contains all the code to do with creating large numbers of new sessions and then creating the attendances to link each member to the session that they're going to go to, session cancellations, all those kinds of things live within there. And all it depends on is the base package for Rockwire, and kind of transitively it depends on our core package. One of the nice things about unlock packaging is you don't have to have everything depend on the base. So one of the other pieces of functionality that we made for Rockwire was this ability to run a report every month and capture the results of that report into a CSV file that's stored in Salesforce. So they can take a snapshot of the report results on a monthly basis. And if you think about it, the code to snapshot those reports doesn't actually need to know anything about the specific objects. It takes as its input a report and it produces the CSV file. So the only dependency it has is on Nebula Core. And then when you install everything in one place, you can feed this module a report which refers to Rockwire specific objects, and it will still work. At the other end of the scale, we have some other packages that have lots more dependencies. So Rockwire use Pardot to do some marketing automation, and our package to handle their Pardot requirements depends on a whole number of things. It depends on Rockwire's base package, because it needs to know all about their data model. It depends on another library from Nebula that we use to help write asynchronous code. And it also depends on a standard managed package. So that's the standard Salesforce Pardot package. And that shows that we can have dependencies even on traditional first generation managed packages, as long as they don't require an installation key. One other thing while we're looking at this is just to re-emphasize that you can move things from one package to another. So as we were building out the Rockwire system, we went through the kind of process that I talked about before, where some of the packages weren't exactly how I wanted to envisage them in the end, but we needed to move through kind of various working states of the system, and we were moving metadata around from one package to another at various times. So what should you put in a package? There are some things which are absolutely perfect for packaging and work really well. These are the kinds of things we're using in Rockwire, where we've had very few problems related to packaging. So these are code, custom objects and fields, custom metadata, permission sets. These are all nicely separated out things that work really well with packaging. Then there are some things which you can include in a package, but you might want to be careful. These really break into two different types. So workflows, process builder, approval processes, and record types are all supported by Unlock packaging, but sometimes with some limitations and difficulties. So we've used record types in one customer and had no problems. We've used record types in another customer and had difficulty building and installing packages. So part of the message there is that, yes, Unlock packaging is quite stable for the yes, package it list, but on some other items you might run into some problems, and those problems may go away as they develop the tooling more. Lightning pages are an interesting case because they're the kind of thing that your admin might want to change in production. And there's always the difficulty that if the admin goes in and changes that and you don't port those changes back to your packaging org, then they'll be lost next time a new version of the package is installed. So sometimes we have packaged those pages, and sometimes we have Lightning pages that use packaged Lightning components but are kept outside the packaging system. So then there are some things which you definitely should not package. And the bottom thing on that list, standard pick list values, that's just not supported by the tooling. So you can't do it today. Profiles and page layouts are an example of the kind of conceptual thing that doesn't fit very well in packaging. They're kind of global things within your system that multiple different modules may want to contribute to. So if you think of the page layout for contact, and you have a module to do HR and you have a module to do invoicing, then it may well be that both of those have things that they want to add to the contact page layout. So it doesn't fit naturally within any single module. And that's kind of a guiding principle, that if something is cross-cutting across your different packages, it is difficult to package. There are examples, though, of these kind of cross-cutting concerns where we just have to grasp the nettle and do something to make it work across multiple packages. One of which is Apex triggers. So following best practice, we'd like to have only one trigger per object, but that becomes problematic in terms of which package should own that trigger and how can we write it so that all the different packages can make their own contributions to it. So thinking of Rockwire, there are two things here that we might want to do with the contact record. We might want to add attendances when someone joins Rockwire so that they're planning to go to them all. And we might want to do some sort of GDPR thing if their contact information changes, to delete them from Pardot. So naturally, one of those functions lives in the sessions package and one of them lives in the Pardot package. Where can we put this contact trigger? How can we have it refer to both of those classes at the same time? The answer is to use a trigger framework that's driven by custom metadata. So what we do is, in the base package, we have a contact trigger, and all that does is invoke the trigger handler framework in general. And then for each of the feature packages, we include a custom metadata record which says, when you're running a trigger on contact, also execute this class. And then we have the corresponding class in the Pardot package. When we install everything together in a integration org or sandbox or production, then all these things get hooked up and all the right triggers get run. So we have an open source version of our custom metadata trigger framework, but there are also various other ones around that you can use or look at and be inspired by. Another point of contention within Apex is test data. So the difficulty with test data is that, again, following best practice, we'd like to have some sort of Apex test factory to create valid records that the tests can use, following all the validation rules and things that are defined within your system. But it may be that different packages impose different constraints on how your records can be created. So that gives you the problem of, where does the test factory live? How does it know about all the constraints that it needs to follow? One way of addressing that is to adopt some coding conventions and say that each object is owned by a particular package, and only the package that owns that object is allowed to add any constraints to it. So that's the only package that can add validation rules or filtered lookups or anything like that. And then that package has the responsibility of providing an Apex interface to create valid test data. That does come with some disadvantages. It doesn't work as cleanly for standard objects, because the standard objects already exist in every single Scratch org that you create. And it also tends to mean that everything has to depend on your base package, because your base package is going to end up owning most of your objects. An alternative that we use is that we have another custom metadata driven framework, which uses dependency injection to create the test records. So what you're looking at there is a list of custom metadata records that we have related to contact in Rockwire. So we've got a base idea of a contact that lives in the base package. And for Rockwire, the email address is required by a validation rule. So the first line of contact creates a contact with just an email address. And then the other different variations of contact start off by inheriting that basic definition of a contact and then adding more things on, like the record type and some other fields that we need to fill in to create a valid choir leader or choir member. If you remember from our diagram of all the different packages we had in Rockwire, the reporting package doesn't depend on the base package, so it doesn't know about these definitions. It just knows about Salesforce standard contacts. So it has a definition of how to make a contact for itself, where it only fills in the last name. But when we install everything together, the test framework sees all this custom metadata together, and when it creates the contact for reports, that automatically inherits the base definition that also fills in the email address, and everything works smoothly. So one of the indications of Salesforce's commitment to unlock packaging is how some of the other technologies they're coming out with are related to it or help it, and some of the other things that they're adding to unlock packaging. So I mentioned before, platform events are a really great way for unlock packages to communicate with each other on a fairly narrow, well-defined channel. That's a very good thing. Entity interfaces are a way for packages to know about object definitions in a more abstract way, which will definitely be a nice thing. Generally, Salesforce are talking a lot more about dependency injection techniques, and certainly that's something that we've used in those two examples of Apex code to work around how packages can do things without being too tightly coupled to each other. Permission set groups are a great way to manage your permissions more easily, and a relatively new feature. And there are a couple of things that the packaging team have mentioned are coming in the future and will definitely improve our lives with packaging. So package bundles will allow you to collect together multiple unlock packages under one single installation ID and URL. And also they plan to allow some packages to depend on the entire unmanaged soup, which will make it much easier for you to transition into a cleaner kind of unlock package. So let's sum up with points for and against unlock packaging. There are some difficulties. One is the Salesforce DX tool is not perfect. Sometimes you run into some problems either with packaging or with the tool itself. And Salesforce are pretty quick about fixing these things, but it can be a complete showstopper until they do fix it. I mentioned the possibility of changes being overwritten. So we have this flexibility of being able to change the artifacts once you've installed them in an org, which is nice and flexible, but it means you have to have the discipline of going back and making that change in your packaging org as well. It's relatively slow to build and deploy if you compare making a change in a unlock package versus making a change in a sandbox that already exists. It does take longer, but the extra traceability and the general modularization benefits of unlock packaging we found to be worthwhile. It requires a different set of skills for your developers. If you're actually going to be writing dependency injection, that's something that's quite unfamiliar for a lot of developers, so that you can wrap it up inside libraries. And it does mean that you may be working in two different packaging orgs at once at some times. That's a different way of working. And it doesn't replace your old method of deploying code. You end up having to maintain two. So we talked about various types of metadata that don't fit within unlock packaging. And to maintain those and also the unlock packages, that means you're going to have two different deployment processes at once. But there are plenty of good points. It makes it much easier to make a controlled release. So when you have the typical thing from a customer where they ask you to write something and then they don't approve you to install it for 6 months, you can just go back to that deployment artifact that you made and install it. And there's no question of trying to remember what should be included and what shouldn't be. It limits the scope of what you have to think about when you're working on any particular modules. There are just fewer classes there, fewer objects, and that's much easier. It enforces the modularity between the various parts of your org. So you could modularize in a traditional org, but Unlock Packaging forces that. Your unit tests will run faster because there are fewer triggers and fewer things around until they go into the integration org, which speeds up your development time. The DX source format, as I said, is really good. And the whole thing really makes it much easier to do parallel development. So any merge conflicts that you have end up being done in source control. And if you're working on separate packages, there won't be any conflicts unless you hit something in integration. So that's it from me. Over to any questions you might have.
Blockchain can help feed more people. And AI can help care for people. VR can help train people. Let's use technology for people to make a greater good in every community, every day. Accenture. New applied now.